Okay, so today we're working on objective 8.1b, and the topic for today is the central angle relationships of in radians. So we're going to talk about theta and theta's partners in terms of radians instead of degrees. So essential questions: how do I find measures of coterminal, complementary, and supplementary angles in terms of radians instead of degrees? And then secondarily, some miscellaneous information. How do I find theta, arc lengths, or radius measures excuse me, of angles on circles that have radii of multiple different values? Yesterday we talked about measures on the unit circle, theta or arc length or a radius of one, always a radius of 1. Today we're going to go with bigger circles or smaller circles than that. Okay, and we'll work in centimeters and feet and yards, etc. Okay, so let's start with coterminal angles. Let me just remind you first that when we're talking about an angle rotation that's given in radians, typically the word radians is optional and it's often omitted. You don't really label things in radians. You can, but it's not required. Okay, so coterminal angles, let's just define that real quick. Those are angles that share the same terminal side but have different measures . So for example, if theta is the measure, to get to a terminal angle, we could add 2 pi times some number n, as long as n is an integer, right? So that just means a rotation, like a full rotation. So n is an integer. So that just means I can go like maybe -2, -1. Those would be backwards rotations, or 0 or 1 or 2, ... So as long as I'm multiplying by full rotations where n represents a full rotation, this is how you find coterminal angles. So here we have find a positive angle and a negative angle that are coterminal with 2 pi over 3. Many answers are possible. So I'm just going to go ahead and draw a circle here and get that located. So 2 pi over 3 just says we're going to take pi, cut it in thirds. So that would be there and there. And this would be 2 pi over 3. That would be the measure of 2 pi over 3 radians. So this would be the angle theta. Okay. Now if I want to find a positive coterminal angle, what I'd have to do is rotate around a full another 2 pi, right? So that would give us a positive, and I'm going to change that to green because I usually do those in green. Maybe I'll be able to do that. Okay, I'm just going to back it up and put it in green because usually my positive angles are green. So I'm going to grab my green pen. So we're going to do a full another rotation plus 2 pi over 3, right? So we're going to start with our measure. Here's our positive example of 2 pi over 3, and all we're going to do is add to that one full rotation of 2 pi, but I'm just going to do times 1 rotation. I'm not going to do times 2 rotations, which would be 4 pi, or 3 rotations, which would be 6 pi. All right, so we're going to do that. So we're going to add those. To do that, of course, we need common denominators, so we'll go times 3 times 3, and that gives us 2 pi plus 6 pi all over the denominator 3, which gives us a coterminal angle of 8 pi over 3. And then if I wanted more, that's one positive, but on your homework I might give multiples. All you have to do is add another 6 pi over 3, which is 2 pi, and that could give you 14 pi over 3, and you just keep adding 6 pi over 3, which is equivalent to 2 pi, right? And so there's two options for positive angles. For negative angles, or a negative coterminal angle, what you do is you start with 2 pi over 3, And instead of adding 2 pi over 3, we want to subtract 2 pi over 3. So we're looking for maybe this measure here, which is coterminal because it terminates at the same place as 2 pi over 3, but it has a different measure. It's a negative measure, first of all, and it's an obtuse angle, or actually reflexive angle. So we're going to subtract 2 pi. Again, we'll go times 3 times 3. And we know it's 6 pi over 3, but we'll go ahead and do the math anyway. So that's 2 pi minus 6 pi over 3, which would give us a negative 4 pi over 3. Okay, and then of course we could subtract another 6 pi over 3 if we wanted to get to negative 10 pi over 3. Okay, and so I'm giving you multiple coterminal angles with 2 pi over 3 because there are many infinite coterminal angles. You know, it just depends on how many full rotations or revolutions you're going to do before you terminate at that spot in the rotation. Okay, so there we have those. Let's talk next about complements and supplements. All right, so if we have angle theta, if theta is my original angle, then pi over 2 minus theta would give me my complement, okay? And then if we have theta and we want theta's supplement, then theta's supplement would be pi minus theta. That would give us our supplementary angle, right? Because pi over 2 is 90 degrees or a quarter of a rotation, right? Because complementary angles have to add up to 90 degrees or pi divided by 2, all right? And so if I want to find the complement and supplement of pi over 6, so pi over 6 is my angle, pi over 6 radians. Its complement could be found by doing pi over 2 minus pi over 6, right? That's how I find the complement. I really don't need to put that in parentheses there, all right? And so again, here we would need common denominators. So we'll go times 3 times 3. So that would give us 3 pi minus pi over 6. So the complement would be 2 pi over 6, which don't you dare give me that answer because you can simplify this fraction to pi over 3. So that's your complement to pi over 6. Pi over 6, which is 30 degrees, and pi over 3, which is 60 degrees. If you add those together, that's 90 degrees. And if you add them together, it's pi over 3 if you're measuring in radians. Excuse me. Okay, so now let's find the supplement. So you know supplements add up to pi. So if this is pi over 6, how many more radians do we need to get to pi, right? So we start with pi over 6, so we want to find the supplement. I'm going to switch to I'm going to change this to red. All right, I'm going to switch to my red pen here. So a supplement, red. Okay, here we go, supplement. So we're going to do pi minus pi over 6 so that we can find the supplement of pi over 6. So again, we'll put a 1 under that and then give them common denominators times 6. So that's 6 pi minus 1 pi all over 6, both of those. And that would give us the value 5 pi over 6. And that can't be simplified. And therefore, there is your supplement. So there's your supplement and your complement. So you just have to switch from thinking of 90, adding up to 90 and adding up to 180 into adding up to pi over 2, to half a pi, and then adding up to pi. Okay? And there's how you do that. It's not that complicated. It's just a little math with some fractions. All right. Last thing here is you're going to be looking at some measures of some different circles. Okay, so if you recall yesterday, we talked about this equation or this formula, theta is equal to S over R. Okay, this is in radians, all right? And if we were to take a circle, and here's our radius, right? And then here's angle theta, and then this angle, or this arc that's subtending it, I'm going to color code that here, would be the arc that's being subtended, or subtending theta. All right? So remember that theta is the central angle in radians. If I want it in degrees, I have to convert it from radians to degrees. Okay? S is the arc length, and R is the radius. P.S. I can rearrange this equation and derive other equations if I want to. So be aware that I could do that. I can take theta equals S over R and solve it for S and get a different form. So if I wanted to say find an arc length, I would multiply times R. And so S is equal to radius times theta. So that's just an alternative form of theta equals S over R. And the other one would be radius equals arc length over theta. So those are the three forms of this formula. You can always, of course, just work off of theta is equal to the arc length divided by the radius if you want. It doesn't matter. All right, so here we have a problem, example 7. Find the measure of a rotation in radians when a point 2 meters from the center of rotation travels 4 meters. Okay, so let's think of that. We're 2 meters from the center. So that's a radius of 2 meters. Okay, and we're trying to find the rotation in radians, right? So we're going to go whip around this circle, and the point is going to travel 4 meters. So it's going to go, there's 2 meters, here's another 2 meters. Let me make that a little smaller so you guys can see it. All right, and then that would be an arc length. So what we want to know is, what is that measure right there? What is that, right? So our S, our arc length, I'll color code this here, is this measure here. The point is traveling from here to here, so it's traveling 4 meters. And our radius is 2 meters. So what's our theta? So remember, theta is equal to S over R. So that's equal to 4 meters over 2 meters. So we're going to cancel the meters, the dimensions are gone, and so that gives us a radius of, a theta of 2 radians, right? So that's 2, and you don't have to label it in radians, okay? Theta equals 2, okay? All right, so you'll have a problem or two like that on your homework. Okay, and then the last example here says, find the length of an arc of a circle of radius 5 centimeters associated with an angle of pi over 3 radians. Okay, so let's draw that. So here we have a circle, and it's going to have a radius of 5 centimeters. So we're going to make that 5 centimeters, and it's going to travel an angle of pi over 3. So if this is 0 and this is pi, I'm actually just drawing kind of a depiction that would be a good depiction. So pi over 3 just means I'm going to take pi and cut it into thirds. So maybe it's about right there, right? So this is the measure, theta equals pi over 3. And what we want to know is, what is that arc length right there? What is that arc length? So we have S, I don't know, theta is pi over 3 radians, and radius is 5 centimeters. So if we do, so this time we're looking for S. So we could take theta equals S over R, right, and just implement that information, or insert the information, use some substitution. So pi over 3 equals S over 5 centimeters. Right, and then you could just multiply times 5 centimeters times 5 centimeters, and that would give you S. So S equals 5 pi over 3 centimeters, and that would be your exact value. And if you were to plug that into your calculator, your arc length would be approximately, to the nearest hundredth, 5.24 centimeters. And there you go. That's what we're working on today. So you'll have 10 problems, or no, 9 problems to practice for homework tonight. Have a good day.